I just updated this one in the morning for the first three. That's all. Hey everyone, good morning, good afternoon. We will get started in a few minutes, just as we start having quorum. And hope everyone is gearing up for the holiday season. I do see some familiar names here. Where is everyone coming in from today? I'm here in New York and it's like super cold. We have like temperatures in 20 degrees right now. It's I was going to say, Brian, I mean, this does not look like your regular office. Hey, Satya, nice to see you from Atlanta. Hey, Richard. So I guess just a couple of minutes and then we can start off. I think we have a lot to cover today. As you might have seen, George is going to cover a lot of our announcements today. So we will not wait till 5 after. I think we'll probably get started earlier. We do see a lot of people coming in as well, so that's good. All right, so maybe we'll just start off and let as people still keep coming in. So welcome everyone. This is the December edition of our community calls today. The last session for 2025, and I think it's been an exciting journey. We did launch this series earlier in the year, actually in January. So we are literally marking a year now. And thanks to all the support that you folks have shown here. I think that's incredible in making this successful. So big thank you to everyone. Um, oh, thanks. And as you might have seen, I think we evolved as we started. We started with just the roadmaps. We evolved that into feature deep dives. I think right now we have like a really jam-packed agenda every month, wherein we come in with announcements, we come in with feature deep dives. Just last month, we put together something called as Experience Exchange, where you're able to talk about your experiences with a particular feature area that our PMs would be digging into. So a lot of things have evolved, and I think as we go into next year, they will continue to evolve. But really, again, just all thanks to you guys. I'm going to do a very quick housekeeping here and then we'll head into the topic right away. So as you all know, we do record this. The sessions are available on the YouTube channel. The link is right here. If you are, if yeah, and then we'll drop this into the chat as well. These are for everyone. These are public calls. We do welcome everyone who is working with AKS to join in. So please do feel free to share this with your teams, with your peers, with your friends, whoever is working with AKS, right? Or whoever you think would want to work with AKS. I mean, everybody's welcome. Uh, Lastly, this is a we want your feedback. We want your questions, right? So we are going to be having open mics. The chat is going to be open throughout this call. So as we go through this, just be mindful of that. We'll just have nice, warm, respectful conversations with all of our AKS friends here. And that being said, I think we'll go into the next slide, and I'll hand it over to George.
All right. Thanks, Sanket. So good morning, good evening, afternoon, folks all around the world. Appreciate you making time to hear about some of the things that the team has been working on over the last few months. I'm going to be mentioning things kind of all the way throughout the beginning of the year in some cases. In a lot of cases, we've been working on a feature and we recently GA'd it, and so we're going to be covering that feature as well. There has been, of course, a lot. This deck is actually not fully complete with all the releases of the whole year. We wouldn't have time to go through even half of them in the time of this call. So we picked some of the most recent ones and some of the most impactful ones from the whole year. And as Sanket was mentioning, I definitely recommend you folks kind of tuning into the AKS community channel in YouTube and checking out the different events that we have posted, like the last KubeCon or previously in India and in Europe. We're going to have another one as well in Amsterdam in the end of March. So in those events, we usually make a roundup of all the announcements that we have done from essentially this time until then. And they're pretty action-packed with announcements, with best practices and more. So if anybody plans to attend or is thinking about it, keep in mind and reserve a day for the AKS pre-day. So without further ado, there's been a few areas of AKS where we always try to make sure that we're connecting the Azure ecosystem all the way to the open source capabilities of Kubernetes and the cloud native ecosystem. And we've been investing in several different areas, from how we want to be present and close to any location where you might need AKS, be it with worldwide regions in the cloud, as well as at the edge, and offer you this elastic capacity and this elastic availability as well across the globe. We want to make sure that we are helping you build or migrate or both modern applications, AI-infused applications, and that we have a focus on proactive resiliency, that we have a focus on running AI apps in a resilient manner, and that we're focused on delivering you with the necessary mission-critical performance, scalability, and reliability throughout all the scale form factors that your mission-critical applications require. I guess as Microsoft's mission-critical service. If you have seen, this is a bit too fast. This is the time there. If you've seen the latest Ignite session that we've done on Scale and Build Reliably, you've seen us present together with one of our internal users, which is the M365 platform that hosts many things, like this Teams call as an example. And AKS is really where Microsoft is betting its mission critical services as well, and why we can stand behind and really assure you that you can bet yours as well. And the last two is really about the efforts that we're making on making security simple and more built-in, and how we're trying to lower the TCO, make the AKS the lowest possible TCO platform for your apps while delivering on all the rest that we mentioned. So one of the biggest announcements of the year, as you might have heard, is the announcement of AKS Automatic. There is now two operational models in AKS. There's a standard operational model and the automatic operational model. And that's really the best way to define the differences between these two SKUs of the service. It is the exact same service underneath. There are no two code paths. There are no key differences between the services themselves. The real difference is really how the operational model presents itself. In standard, it's really you have the ability to build your own story, to bring your own opinions, and we provide you a managed Kubernetes service. In automatic, it's a bit different. Kubernetes is a large space and has a lot of options and a lot of optionality, and AKS alongside that as well. And so that can bring a lot of different notions that you might need to know, or that you might want to know in order to better architect your application or your environments. You might need to choose specific CNI plugins. You might need to configure networking. You might need to configure storage. And AKS provides you with all those integration points and all those options. But if you're not already interested in building your own story, you just want a platform that runs itself and you just want to deploy your apps, that's where Automatic comes in. In Automatic, Microsoft takes care of all the operations, and it also takes care of all choices and opinions. So the only thing really that you use in Automatic is the Kubernetes API to deliver your apps. And even that use of the Kubernetes API is very much guardrailed, using the things like deployment safeguards to ensure that the best practices are guaranteed, and allowing us specifically in AKS to deliver things such as SLAs. So in standard, you already have things like the API server uptime SLA. That's the guarantee for the control plane that we host. But in Automatic, because of all this new operational model, we are now able to guarantee as well pod readiness SLAs. And this is a space that we're going to be working on very, very significantly, again, aligned to our proactive workload resiliency streams that I mentioned. We want to make sure the service goes more and more towards guaranteeing your workload and not make that necessarily your responsibility only, beyond just guaranteeing the service reliability itself. And one of the key things that we also announced recently, we're super excited about, it's been one of the biggest engineering feats that we've done since the launch of the service, is the launch of the AKS Automatic Managed System node pools. These node pools are actually present in your cluster. You can see them when you go kubectl get nodes, but you don't actually see any VMs or infrastructure for them. So whereas in the past and in standard, we typically recommend that if you're running a production grade system, you have a system pool, which is where we recommend that you run exclusively the system components. And those are shared throughout the cluster, things like core DNS or metric server. And then you have your user pools, which is where you would then deploy your applications throughout, and you can deploy as many as you want. You can have as many node pools as you want and beyond. But one of the things that did, especially at low footprints, for example, a small environment, just deploying one app or deploying one app with a very small footprint, a few instances, for example, that would mean that you would have potentially 2 node pools with several nodes for maybe 2 replicas, which might become a big overhead. So AKS will always perform excellently in terms of cost savings as you scale. But if you're starting very, very small, that could be a challenge for you if you just want to, start with a platform that you want to then scale on. So because of that, and also to ensure much more reliability, much more predictable performance, we've tried for many years to bring all the components that typically are required by the nodes into our management plane, into our area of responsibility and ownership. And we've now succeeded at doing that. So things like core DNS, things like metric server, they're no longer required to run in your nodes. They are now run by Microsoft. And that also means that you don't need those system pools. You'll see them because those components need to be accessible. They're still dedicated to you. There's no multi-tenancy here or anything of the sorts. It's still the same exact thing as if you were running these node pools yourself, except we're running them now. And the key point is you're not paying for them. So you're no longer paying for them. Automatic already has its pricing that is priced for your applications as they scale. And that's what you're paying for. It's the cluster fee and then the scaling of your applications themselves. So that allows you to have at a very small footprint, 1 application, 2 applications, a very, very performance and ready to go to hyperscale service while still giving you the price as well as the experience from a developer perspective to have everything taken care for you, to have all the best practices infused and more. But what if you don't have new applications? What if you're migrating from some legacy applications, be it from on-prem or other systems? This is an area that we've been partnering a lot with our developer divisions and folks in the company that specialize in languages like Java or .NET. And we're very happy to announce the general availability of the GitHub Copilot app modernization framework and set of tools. And one of those key tools that are part of the GitHub Copilot app modernization suite is the AKS Containerization Assist. The AKS Containerization Assist is part of this app modernization toolset because there's several points when you do a migration. You need to, in many cases, you need help from a code system like GitHub Copilot to, for example, modernize your code. you might have an old Java version, you might not be using the right data backends, you might need to update things to allow them to run in Azure. So all of that is something that the assessment phase as well as the remediation phase of the migration toolset helps you with directly from VS Code and directly with Copilot. Then the second stage is, okay, so now you've modernized, done some changes. How do you deploy those changes and that modernized application into a modern service like AKS? Well, Containerization Assist helps there. It will produce Docker files, it will produce manifests, and it will test them and iterate through them. So it's not a one-shot type of approach. It's a more AI-based type of approach that it will try to deploy the application. It will try to push and run the container image, and it will also try to deploy the manifest that it generates into the cluster. What that means is that even if it fails, it will register the error and it will try to correct it. That is particularly helpful if, for example, you're deploying to an automatic cluster and maybe you don't know about all the best practices that are enforced in an automatic cluster, because that allows Containerization Assist to apply those for you into the manifests. So for example, even if Containerization Assist for some reason wouldn't add resources and limits to the YAML manifests of the applications by default, which it does, it wouldn't be able then to deploy. So it would get an error saying, hey, this is blocked by policy. You need to have requests and limits in all applications. So it would go back and it would add those and then try to deploy again and see that it validated and that it succeeded. And this is applicable to not only the automatic validations, but also all the way to your own policies. So if you have specific policies that say, for example, hey, I need a cost center, otherwise this breaks my policy, that error will come back and Copilot will adjust to it and say, hey, I need the cost center for this. I added this placeholder there. If you tell me which cost center I should add, I'll just add it for you as well. So all these kind of things, Containerization Assist is able to help you with, no matter what stage of familiarity with Kubernetes you might be and how many applications you've deployed to it. Next, we have, of course, how we are making Azure an AI-optimized cloud, how we're making AKS an AI-optimized platform, and it starts with all of our infrastructure that we provide. And one of the key things that I think is the best roundup announcement that we can position, that we can talk about in this area, is the fact that the CNCF has announced and launched a AI conformance suite and framework, and AKS is a certified service and an AI conformance service according to the CNCF new framework. This involves a ton of different requirements that AKS is meeting and is evaluated for every single Kubernetes version, the same way that Kubernetes conformance is also evaluated for each version, and then services need to ensure that they comply with that in order to be a conformant distro as AKS is. And this includes a number of different things, from managed drivers that are available out of the box to all the way to flexible capabilities that you might want to configure yourself. And so AKS, as always, provides kind of that duality aspect of it, providing you kind of the batteries included, but replaceable approach that you can always count on. One of the announcements inside of this AI optimized infrastructure area is the addition to the management suite of not only the container GPU drivers that are running on the underlying hosts, but also the device plugin. So the drivers usually allow containers to make use of GPUs, of accessing those GPUs, making calls to them, etc. Whereas the device plugin, historically, what it does is it announces and publishes how many resources, how many GPU resources do you have towards the API and the scheduler, so they know where they can place your requests, and they know how many of them are available. So it essentially tells Kubernetes, well, one of them tells the node and the kubelet and the container the GPU resources. The other one tells Kubernetes how many and where they are across, simplest way to put it. And that has been a daemon set that you would run in a GPU cluster that we have images maintained and patched for it. But we wanted to go even further and make that a fully managed component, as well as that we manage a lifecycle for, that you don't need to install, that you don't need to even think about. And that's what we're announcing here now. You have the out-of-the-box built-in NVIDIA device plugin added to the NVIDIA drivers that we already managed before. This is currently in public preview and it will go GA in the upcoming months. Next, an important call out, speaking of publishing and also kind of the resources for GPUs, is the dynamic resource allocation work that has been completed upstream and is available on AKS on 1.34 plus. And it's one of the key requirements as well for the AI conformance to pass, is the ability to install the NVIDIA DRA drivers and to use those there. So this is a new way to request GPUs versus what before was using a very static GPU 1, GPU 2. With this, you can allow for much more flexibility. So you use GPU resources in a very similar way to how you use storage, for example, where you might have a storage class that indicates all the definitions and configurations of that storage, the type of storage, a lot of the different configurations like security configurations or performance configurations. And then you have volume claims that you refer to in the pods that go to that storage class and provision a little bit, a piece of it that gives that persistent volume that then the pod actually uses. So that's how now GPUs and more broadly, these kind of resources, there are not just CPU and memory, but all kinds of resources, for example, in the networking space and more, you're going to be able to specifically carve them out and say, okay, these ones are from my pod. This allows for a lot more flexibility, where before, just like here's a pod, here's a GPU, go use it, and then you need to get that pod away, bring another pod to do that. With DRA, you have a lot more flexibility, and you let Kubernetes then do that management as well for you. And on the AI infrastructure stream still is a networking announcement. Where does this kind of add up in the AI infrastructure piece? Well, one of the key things for deploying models is to properly route to them and to route to them in a way that helps your inferencing needs. For example, you might want to route different things to different models depending on, for example, specific topics. You might want to install a semantic router and then say, go to 5 for math, then go to something like Llama for general questions or DeepSeek or something like that. And for that, you need to have these routing capabilities for things like, for example, inferencing gateways, which are part of the Gateway API project. And that project is implemented down in Azure in 2 different places. One, you can use it with the Istio Gateway, and 2, you can use it with that's an in-cluster gateway option that we have, and 2, you can use it with the application gateway for containers, the new AGC, and that is now becoming an add-on in AKS so that you can make easy use of it, easy installation. It has all the lifecycle managed for you. The next that we have here is also on kind of the scalability side of the house. In order to make granular use, and this is something we announced towards the beginning of summer, is a new type of node pool. You probably have been familiar with the AKS node pools for those of you that have been using AKS for quite some time. And you know that those node pools are typically a uniform set of nodes. You can put some labels, you can put some taints, and they have a skew assigned to it. And then you can use close autoscaler to scale them up and down. You can have multiple of them and scale them also up and down with it. That, I think, was very, very good. And a lot of you have been making success and having success with it for quite some time. But there have been some challenges. And for example, when you think of GPU, that's already some of the interesting challenges with it, where you might want to actually have some heterogeneity inside of the same node pool. You might want to have different GPUs, or you might want to have, even in the CPU space, you just might want to say, I just want general purpose SKUs, and I don't really care which one. And I might want to scale them independently, maybe because of specific reserved instances discounts or specific capacity in that region or something like that. And you can now do that without having to create new node pools. That is achieved through the new virtual machine node pool concept that AKS now has, which instead of being that uniform block where everything is the same, because again, it's uniform, you actually have scale profiles inside of this node pool that allow you to have, for example, 5 nodes of a D4, 10 nodes of an E8, and henceforth from there. You can still have multiple node pools because you're going to have very different kinds of SKUs, for example, that don't make sense to be together. Like, for example, would you be scaling in the same node pool a GPU and a CPU? That doesn't really make a lot of sense because you usually want to have different labels across them and things like that to separate those kinds of applications. So for different environments or isolation or tenancy or just very different families and requirements, you might still want to have different node pools, but you don't need to have them if the only reason that you were going to additional node pools was just adding different SKUs. That also allows you to manage your own capacity and quotas and things like that a lot better. For example, you don't need to go to a new node pool just because you ran out of quota. You can just add some other SKU into the existing node pool and allow your applications to stay there. One of the announcements that we've done recently on this thing that we announced over summer has been, one, it's GA. It's currently our AGA. And B is the auto-scaling support for it. So autoscale now is able to scale those profiles in the same way that you were used to with node pools. Next, we have the scheduler profiles. So one of the key things that you need when you're scaling AI apps, when you're scaling models and beyond, but also when you're using it for your existing applications and your existing needs, is that there's a lot of configurations and a lot of plugins you can use from the Kubernetes scheduler. And AKS runs a default configuration, again, being 100% vanilla aligned. And you could go on and run your own scheduler if you want, and then you can reference it in your workloads if you want that specific configuration for that scheduler for that workload. Because the reason is the default scheduler is really the best for general purpose. That's why it's the default one. And then every other scheduler approach is kind of very specific. So you need to know what you need. You need to apply it to the things that you need. But there are many cases where you might have the full cluster dedicated for something. You might want to have your full cluster, for example, using node bin packing, being very aggressive with bin packing things across the node. And instead of that, instead of having then kind of the spread being the default and using your infrastructure the best way possible, you might want to prefer to pack first, so that then autoscaler maybe, for example, takes more actions and crunches your cluster and your costs further down. So for those cases, you might want to change the default scheduler, and you might apply it to the whole cluster. And you might not want to run your own scheduler because you don't want to manage another piece of infrastructure and then have to reference it to all your workloads. So AKS now allows you to configure scheduler profiles in the default scheduler, allowing you to say something like, hey, I want for the bin packing, or in AI and ML cases, I want job queuing policies. So for ML workloads, you might want to have very different scheduling approaches. And again, if this cluster is all just for AI ML, then you might want to make that the default as well. The AKS system components will still use a default schedule. They reference it explicitly, and then your workloads will use the one that you pick as such. And next, a very important point that we have is that we are adding a ton of GPU-specific detections into Node Problem Detector, which is a component that AKS manages that runs in the nodes and provides you, as well as the system, with conditions and events for what's happening in that node. It already has a ton of things, including GPUs, but very, very generalist. So it would check, if the node is not ready, if connectivity is down, if there's any degradation on CPU or GPU and things like that. But GPU and AI scenarios have very specific conditions that we can add, and they have very specific faults or fault types that we can check for. For example, you can have driver issues. Again, on the drivers that I mentioned before, it goes all the way to different levels, because there's all the levels from the device plugin that I mentioned, the container drivers, all the way to host and physical rack drivers that need to be installed. And so because of all those very niche and specific possible faults, we've enhanced Node Problem Detector to surface them, as well as our remediation capability to attack them. So even if it's something as specific as an NVLink degradation or the InfiniBand having issues, this will detect it, will publish it. And in the cases, similarly to how we treat the rest of the remediations, if something is unavailable or if something is unrecoverable or will be unrecoverable, we will take an action, even if it is, for example, redeploying the node. If something is degraded, we will publish that information and we'll allow you to take the decision. And we're enhancing the remediation capabilities to give you also the option to choose what happens in those cases. In many cases, you might have things that are stateless, and you might just want things that are even like freezes and whatnot to go and just spin up a new node and things to be drained. But on cases that maybe are stateful, you don't want that to happen. The disruption there might be too big, so you actually might prefer to wait for 30 seconds or something like that, because that's still much faster than backing up and restoring your state to some other node. So this kind of capabilities are coming in at the beginning of new year to the remediation capabilities, and those are all already integrated with these GPU health detections. Next, we have on the reliability front, something that we have continued to improve, and there's really not a lot more than we can do from just pure reliability. So we're, as I mentioned, going more and more into the workload scenarios and into how to protect with very, very edge scenarios, very, very niche scenarios. The AKS control plane and clusters already out to scale. Nodes have things like I just mentioned, like node problem detector or remediation. We have all the auto-scaling capabilities, not just on the system side, but also provided for your applications, and a lot of different resiliency mechanisms, fallback mechanisms for things like DNS and beyond. We're going to talk about node local DNS later down the line. That is a great resiliency mechanism for DNS failures in upstream DNS servers, and how it complements core DNS very, very well. And how we've enhanced it to create AKS local DNS, something that's going to become a default in all clusters. So those are the kind of scenarios that we're pushing the boundaries on. And one of them is the managed API server guard approach. So this is, you can think of it for cases where maybe someone in your team installed something from online in some dev cluster, and it just is trying to host the API. This happens a lot more commonly than maybe you might think. Because a lot of projects are really, not optimized for large scale, and so they might work fine in 2-3 nodes, but then, or with just a few objects, but then in your real clusters, that might start to send, for example, unchunked list calls and list operations, which are extremely costly to the control plane, and they might actually, by mistake or on purpose, hopefully not, try to DDoS your API server, try to do almost a denial of service by just issuing all of these super costly list calls and try to make its latency really go down, try to make its resources go really, really up. And it can make it unavailable to the rest of the resources because that specific client is hogging out all the API instances and more. And in those cases, scaling it more and more and more is really not the best approach. Like there's only so much you want it to scale for. Like you don't really want to scale your infrastructure to respond to a DDoS attack, right? You want to stop the DDoS attack. You want to block it. And so this is the kind of thing that API Server Guard does. It will protect the control plane from excessive and overloaded inefficient list operations. And these are really one of the ones that we see, let's say 90+% of the time. And so we're using those learnings to bake some of these newer features. 90% of the time, it's just a component that just doesn't know how to properly do lists, which unfortunately is actually a lot of the open source projects that are not tuned. And this provides automatic protection for it. So if this happens and the API server is going to start to go completely unbounded, the pattern is just going to go up and to the right in terms of calls, and it looks unbounded, you'll get throttled for that specific component. So that specific agent is going to be disallowed from doing any more calls, and this protects the rest of the service, all your other applications, all the system components from continuing to use the API normally. And you can then go and kind of say, oh, this happened, we need to go and take a look. Maybe it's something that you happen to develop and this has a bug. You can go and fix that, and then you can ask us to allow it again, and we'll do it again and again. As long as that's fixed, then everything is normal. If that is not fixed and happens again, then it might be disallowed once again. The final point to mention is we announced throughout the springtime the ability for you to use fleet management for business continuity. Oftentimes, you can already have so many systems that you can use in combination with fleet management, and you can already orient and organize yourself to have the same application running in multiple regions. But the fact is, you never really have the same application running in multiple regions. You have copies of an application that the systems treat as different applications running in different regions. It's only you, the human, or the automation that you have that tries to treat them as the same applications. For Kubernetes, they're not. There's one Kubernetes here and one Kubernetes here. It's running application A, but it's not really the same application. It's just two applications that just so happen to be called the same. With fleet management, you actually have this concept of namespace sameness and application sameness, where it allows you to use clusters as topology. So the same way that you use nodes as topology or zones as topology, you can now start to use clusters as your topology factor to say, I want to spread my application across these different clusters, across these different regions. I want to have two. I want to have them in all my clusters. And you can really use it for enhancing your business continuity, recovering things. And now you have, when you use a hub, because you can run fleet in a hub or a hubless way, you can have that extra brain taking care of those capabilities and monitoring if things succeeded at deployment or not, in the same way that Kubernetes monitors and acts if something didn't schedule to a node according to your topology constraints. Next, we have capacity and fungibility. And in this area, there's a lot that we've been doing, from adding smart VM SKU defaults to adding SKU recommendations in Portal in case you're picking a bad SKU or a SKU that is not the most appropriate for that region and that cluster. Portal will just create a pop-up and say like, hey, actually, we would recommend these if you're trying to select that SKU. We've done a lot of settings for upgrade, from drain timeouts to soak time configurations and GA those. We've allowed you to upgrade in place when you use max and available. So for cases where you might not want the regular AKS surge behavior, where there's a new node or nodes that come up and you upgrade using those nodes as your buffer, you might have enough buffer in your cluster. So for cost reasons, for capacity reasons, you name it, you might want to upgrade in place. And you already run with 20, 30, 40% of a buffer. And actually you could fit maybe one by one all the applications from one node across the existing infrastructure. So max and available gives you that ability to do that. And finally, in terms of scaling and surges, we already discussed VM node pools. We already discussed the auto scaling that a VM node pools that already has. We also have capacity reservations, which you can use for things like upgrades. So you can actually assign a capacity reservation that you reserve to yourself. So you could say, I have always guaranteed in this region to have 10 VMs. And you can use those 10 VMs actually across different clusters, and you can apply them at a specific time, for example, when you're upgrading, so that you guarantee always that surge that you're going to have there. And once you're finished with the upgrade, you can go on and maybe upgrade another cluster and apply the capacity reservation there. But one of the key things that I think are very interesting is node auto-provisioning that you see on the far right. And that's something that we GA'd over summer, and we launched it late last year. Late 2 years ago, and had last year as a preview. And it's something that we're very excited about, because not only it allows the same as the VM pool concept where you can mix things, but it actually doesn't require node pools at all. So in the VM node pool scenario, you're still adding node pools. You just get to have all the flexibility that of mixing SKUs inside of them. But with node auto-provisioning, you don't even have node pools. Node pools don't exist in a node auto-provisioning type concept, and that's how Automatic works. So what happens there then? Well, what happens in those cases is that there's the scheduler and the scaler work together, and they are going to just-in-time provision the type of infrastructure that you need to have the most efficient and most available environment for your applications. What does that mean? Well, for example, if you're using Autoscaler and you have 3 node pools, the first thing is you need to create those 3 node pools. Even if you create them with 0 nodes, you need to still create them. Second, you need to turn Autoscaler on them. Third, you need to deploy your workloads, and they're going to go pending because those 3 node pools are at 0. And then Autoscaler is going to scale them Maybe you have GPUs and it's going to scale the GPU one. Maybe you are preferring Spot and it's going to try and scale the Spot one. And when things go inefficient, it might scale them in, it might scale them down, etc. That is not necessarily the most efficient case. Like you might be 100% efficient using this, but it requires you to configure it. And as in Automatic and beyond, we don't want you to have to know how to configure things to be the most efficient. So Auto Provision delivers that kind of off the gate. It actually just looks at your requests from your pods, from your applications, and say, okay, this application needs 2 GPUs. Do I have 2 GPUs in the cluster? Yes, then I'm just going to place them there. If I don't, then what's the most efficient way I can to serve this application? Is it going to be to create a two CPU VM? If so, then it's just going to create a 2 CPU VM, and it's going to select the 2 CPU VM that is the cheapest and most available in this region. And if you allow for things like Spot or ARM64, it's going to pick from those as well, which are always going to be cheaper too. But in some cases, it might actually be cheaper to create 1 or 2 different VM SKUs and balance out things from your cluster. So it not only selects the best thing at scheduling time, but it also has this consolidation cycle that it will look at your cluster in your maintenance window. For example, your maintenance window is on Saturdays at 11 a.m. And it will, on Saturdays at 11 a.m., look at your cluster and see, I've been deploying, the user deployed 4 applications at different times, and we happen to end up creating somewhat very approximate VMs at those 4 different times. So let's say that all your applications need 3 CPUs, and the system created 4 CPU VMs, because that's what the SKU numbers are in Azure. You could create a 2 CPU or a 4 CPU. But if you create 4 CPUs, then you always have 1 CPU to spare. And you can't really fraction it because the application always needs 3. So what happens now? And in a cluster autoscaler world, it couldn't scale any of those nodes down because they're over 50% utilized. The cluster is pretty decently optimized, but is it as optimized as it could be? Well, you can already do the math, right? It isn't. You could actually create a bigger SKU instead of a 4 SKU and load some of those applications there. If you can, maybe even load all of them there. If there's no other restrictions like topology and availability, maybe you already have other nodes and with other instances of those applications in different zones. And you might just say, oh, instead of having 4, 4, 4, 4, 4, I'm actually just going to create in each zone, let's say a D16, and load all these applications there. In that case, I'm only going to be not utilizing 2 CPUs, whereas in the previous example, I was utilizing 4 CPUs. So NAP does all of this for you and does this consistently and recurrently without you having to do anything for it. So we'll do that every single maintenance window, every single consolidation cycle. And so that's the biggest power of it. You no longer have to deal and create node pools. You no longer have to select SKUs, although NAP has configurations, of course. So it doesn't restrict you from doing anything. You can still go in and say, but look, I don't want you to pick anything outside of the D and the E family. That's okay. Look, I don't want you to mess around with Spot or ARM64. That's okay. So you can configure NAP to do exactly what you want it to, and then it's going to use that to its full capabilities. Of course, it's more powerful the more you give it a kind of reign, because then it's going to be able to look at the whole scope of Azure. And you always know it's always going to choose the cheapest option for me, and it's always going to choose the most available option for me. And in terms of consolidation, it always follows your maintenance schedule. So it's whenever your maintenance is scheduled to be, which is where your upgrades are also going to happen if there's upgrades, or consolidation means oftentimes not just repacking the cluster. It can also be an upgrade. So consolidation is really just a word in NAP that says, I'm going to bring things to the desired state. So in cases of packing, is making sure that things are efficient. In cases of upgrade means, oh, there's an upgrade, I'm going to bring this to the new version, be it from the node or for Kubernetes. Finally, the same concepts that NAP has, you also can apply them to multiple regions. Regions have different pricing, regions have different capacity, and so you can always use things like the same intelligent placement capabilities I mentioned before for business continuity. You can apply them across the world as well. So you can now say, I want to go to the cheapest location. I have clusters across the world. Maybe they're all with a very small footprint. and I'm going to send it to the cheapest location. And it's going to be Fleet Manager doing something very similar to what Auto Provision does, that is going to select the region based on the price and the SKU, and it's going to place it there. You can even combine both of them inside of each region. Next, we go to observability, and there's a few interesting announcements. The first is the general availability of the Azure Managed dashboards with Grafana. And you might be like, wasn't Grafana already, Managed Grafana already GA? Yes, yes it was. The key announcement here is that in the past, you had to go to the portal, monitor, then you'd click Azure Managed Grafana. That would open up a new kind of portal, the Grafana portal, where you'd go, you'd add dashboards, you'd see the built-in dashboards, all the good stuff. That's still there, but what a lot of users wanted was to have that readily available just next to their apps, just next to the deployments, and embedded in the portal. And so that's what the Azure Monitor dashboards with Grafana are. They're embedded Grafana dashboards in the portal that you can use, and you can still do the exact same actions. You can look at them, explore them, create new ones, use a built-in, etc. And this is now fully generally available. For Windows cases, a lot of gaps were in the Windows monitoring because in Linux there's Windows there's Node Exporter and for Linux Node Exporter that automatically send metrics. For Windows, we've had this feature in preview for a bit, which is called Windows Node Exporter, and that brings parity to a lot of the node metrics that are exported out from Windows nodes. That's now finally generally available, and it's readily packed inside of your node. So there's nothing you need to do for this. This is an FYI. What you need to know is that all Windows nodes, if you're using Windows, are going to be sending the same type of metric as your Linux nodes by default now to your Prometheus, Grafana, etc. environments, or any tool that you have scraping the nodes. This will now be exporting the metrics from them. And one final thing in terms of monitoring is the new Kubernetes Center. So you might notice in the Azure portal some changes coming in soon. And for those of you using preview versions of it, you might already be seeing it, which is a new blade where you used to see things like the list of your clusters. You're now going to see more rich information. You're going to see the versions that they have. You're going to see the splits from them. You're going to see any possible, you're going to see some single pane of glass observability for all of them. They don't really have any logical concept that requires you to put them in a fleet, which you'll find in that exact portal as well. The recommendation to say, hey, do you want to add these clusters all to a fleet? Are they all part of the same fleet? And once you do, you're going to get the logical views for that fleet, like if they're running the same application, or if there are different environments like dev, test, and prod, and how that looks like. You're going to be able to do upgrade management for them, stage rollouts, so you're promoting from one environment to the other. But if you're not, or there are multiple fleets, and you still want to see something like the Kubernetes version split across them, this is going to give you that exact view. So it's kind of a more enhanced list view for clusters that allows you to do some visualization and actionable insights for you. Next, we have the area of safe rollouts and changes. And I just mentioned that one of the key capabilities that Fleet provides is exactly safe rollouts for your workloads. But it also allows you to configure update groups for your clusters so that when AKS is doing releases or auto upgrading, or even in the cases where you might want to just manage the upgrades yourself, but still doing them in a way that doesn't require you to write complex automation, Fleet Manager can help you with that as well. So there's a few things that we're announcing in this to enhance these already existing NGA capabilities. The first one is the approval gates for these update runs. So what happens in these situations is that you are going to be able to have either before a stage starts, and a stage could be, for example, your staging environments or your dev environments. That could be the whole stage, and you can have multiple groups across them as well. Maybe the groups are the different regions that you have in that stage. You're going to be able to have pre and post approval gates for it. So you might want to have a human going there and say, okay, staging looks fine, let's move to production. Or you might want to have automation, like if something is doing some health checks, and then that is going to say, looks good, automatically approved, and it goes. So your upgrade flows completely automatically, but still with all the different checks and gates that you want to put inside of it. And as I mentioned in other cases, you might maybe want to run like this for your patch channel, but maybe you want to do the minor version upgrades in a very targeted way, or you might have your fleet in a very heterogeneous way when you start, and you might want to bring them all to consistency. So the Kubernetes target minor version is pretty helpful for it. So instead of you having to just be on auto upgrade and rely on gates and everything, you can just say, no, I'm just doing that for patches. But for minor versions, I want to reuse the pipeline that I already have with my update stages and more, but I want to automatically run this one this time. I still wanted to use the gates. I still wanted to use the soak time. I still wanted to stop if something fails automatically, all that kind of stuff. And everything is going to go to the same consistent version from there onwards. So you might use it to go to 1.35 now, as an example, and all your clusters are going to get there. Even if there's some of them in 34, some of them in 32, some of them in 31, God forbid anything older than that. So those are the kind of things that target minor version allows you to do. So it's kind of, you can think of it as the manual upgrade in a cluster, but you can put it in a fleet as well. So you can get all the consistent versions spread across your clusters in that order that is so important for you in your own kind of safe deployment approach. And moving from the clusters into the workloads, that's where workload placement once again comes in with these staged update strategies. So very similar to what we just saw, but for environments, you can do that for your own workloads. You can say you're going to promote something from dev to staging, the workload itself now. You can do that, and you can have things like gates. You can have hooks in there. You can have specific time that you might want to wait, and you have all those capabilities, but now for your workload, so that when you are deploying the next version of your application, you can approach it in a very similar way to how AKS approaches upgrades, for example. Next, we have an area for those of you that might already have the title of platform engineer, or for those of you that are doing DevOps or that are running clusters on behalf, which is the efforts that we've been doing to have productivity, more and more productivity for folks leveraging and using clusters. There's a ton of different areas that honestly still have a lot to do. So you can expect a lot from us in these areas, and we'd love to continue to connect and use these calls to see what's most pressing for us to go solve. We want to really empower platform teams and their respective users and customers, the developers, to continue to provide the best platforms and the most productive platforms. So there's a lot that we need to do. Here's a few things that we did just this year. The first is the announcement of AKS Desktop. This is a new desktop and browser tool based out of the open source Headlamp tool that you can find in Kubernetes UI. And that allows you to, from your own desktop, like a desktop app, like you can think of Word or something like that, you're going to open up, log into Azure, load up your clusters, and manage them from there. And that's all you get. So for teams, one of the things that we've heard a lot from platform admins is, I don't actually want to give my developers, for multiple reasons, access to the Azure portal. Either because I don't want to have to be bogged down with role-based access control to ensure that they only have access to what they need. Like, I mean, they don't ever going to need anything else. So why would I have to do all of that? I just want to give them a view of what's more relevant for them, which is their applications, their deployments, their Kubernetes clusters. In fact, they might only have access to namespaces. So why would they have to go into the big Azure portal for it? So in AKS Desktop, you just see that. Now, one key thing that we saw was in Headlamp, you basically would have to bring in your kubeconfig. So you had to go, get your kubeconfig from somewhere. Again, it could be the portal, it could be the CLI, and then you would load them in, and you'd have your clusters, and then you'd go happily ever after from there. But it's not super dynamic, and it's not super easy. So what the AKS Desktop does on top of Headlamp is it's an AKS and an Azure-specific plugin that allows you to log in, allows you to grab your clusters, load up your clusters or namespaces, and then access them. If you're using Automatic, as we demoed in the recent events, then you already get metrics out of the box. You already have flows of deploying your application out of the box. And not just that, it's already integrated with managed namespaces. So managed namespaces is the ability for you to provide fully curated namespaces to a team. You just give them access to that namespace. You can already decide if that namespace can have any external connectivity or not. You can already decide what kind of network policies you want in them from the different defaults that AKS provides you. And that in AKS Desktop, when you create a new project, it actually uses managed namespaces. So if you're creating that to your developers, then that's exactly the only thing that you see. For many of you, you are both, right? You have both hats. So you can still use it for both. You can create your managed namespace and then leverage the application creation flow after that. And you can do both tasks. But usually, you're likely going to be in a situation where maybe someone created the namespace for you. Then you're going to go and navigate into that namespace and then do the application creation flow that we provided that allows you to start from a container image, from something that containerization assist created, like the whole set of YAML manifests, and then you just load them in and deploy them into your cluster. And not only that, but you also have these managed namespaces that AKS secures and allows teams to hand off to their developers across fleet. So in the cases that I just mentioned where you might be using business continuity and you have that notion of same namespace, Fleet now allows you to have these same managed namespaces. So the same policies are applied. It's the same namespace across all these clusters, and the developer doesn't even know. It doesn't need to know. Like, they have access to a namespace, they're deploying to that namespace, done. That's all they need to know, and then they can put in, I want these things as spread as possible. Cool. And then under the covers, it might be in 5 clusters, and it's going to be in 5 clusters. Next, we have AI for productivity. So it's a key area for us to ensure that you can leverage AI to do actions and to be productive. And we have 2 quick announcements to mention here. They're very quick, but they're very powerful. So if you're not using the agentic offers that AKS already has, I definitely recommend you take a look as soon as possible. They're fully open source, and you can install them, use any LLM with them, and more. First is the agentic CLI. So this is, AZ AKS agent, as you see on screen, and then you go from there. You can ask it to inspect your cluster. You can ask it questions. It will run kubectl commands with your permission. It will use your access, so on and so forth. And then the second that is integrated with the CLI agent is the MCP server. So this allows you to use additional tools in your tasks. For example, it might use Inspector Gadget to go and inspect how your cluster is. It might use specific monitoring that it has access to check the health of your cluster. And you can use it to do actions, for example, to check the readiness of an upgrade. AKS already does a number of checks, but this can go all the way to your apps, can do all kinds of specific things. You can continue prompt it with different questions and aspects to confirm that everything is ready for an upgrade. And then it can help you trigger the upgrade itself and ensure that everything is following those best practices. Next, we have system multi-cluster management. I already mentioned to you about things like upgrades and how you can do that across, but sometimes you go even beyond cloud. It's not just AKS. You might actually have a bigger footprint. You might already have things deployed at the light edge or the heavy edge. You might have on-prem, etc. AKS offers solutions for all of this. You can have AKS Cloud in Azure. You can have Edge Essentials if you're doing in a light edge or a disconnected way. You can even have AKS on Azure Local if you're purchasing hardware to have your own little data center or a little piece of Azure in your data center. But how do you then bring back some of the workload placement pieces that we saw, some of the fleet-based additions that we saw when you're, for example, in a bunch of retail stores and you want to deploy an application to them? And maybe you're already using GitOps, but you also are interested in the capabilities of those staged rollouts, because GitOps and Argo, for example, is super good when you're doing something in a cluster or you're pushing to multiple clusters, but it doesn't have really this notion of staged rollouts across clusters. That's where Fleet comes in, and Fleet integrates with Argo. And we're going to be actually making a big integration with our current private preview of Argo CD. It's going to integrate with this Fleet workload placement to do these staged rollouts across clusters when you're already using Argo to deploy to them. And that is because Fleet also integrates with Arc-enabled clusters. So any cluster, even if it's in a different cloud or beyond, you can Arc-enable it, and that means you can add it to Azure Kubernetes Fleet Manager. That means that the kind of full picture becomes true with Fleet looking at AKS, other managed services in the cloud, as well as edge and hybrids footprints as well. We talked about performance for a bit, so I want to mention a few announcements here. But I want to highlight one, which is the one I mentioned before, which is AKS Local DNS. This boosts the performance, it boosts the reliability, it allows you to fall back from UDP to TCP, it allows you to configure additional pieces, it has a cache in every node. It's just, we've been running it across our biggest users with incredible performance benefits that you can see on screen. It's just so good, and that we're going to actually make it a default on AKS. This is now GA. You can go on and turn it on. If you have clusters, go on and turn this on. There's just nothing that you need to think about beyond that. Just go on, turn it on. If you want to further customize it, take a look at our documentation. There's plugins that you can use. It works in combination with Core DNS. Doesn't matter if you use automatic. Doesn't matter if you use standard. Just go on and turn it on. It's the quickest thing I can say. This is so good that we are going to make it default in every AKS cluster in 2026. So definitely super excited that this one is now GA. Take a look at it. And I'll give you any feedback. But right now, we've had folks that in recent outages, as an example, that we never want to happen. But when these things happen, is why these resiliency features exist. And because this has a surf stale capability, it actually can prevent upstream DNS issues, even if they are your own DNS or Azure's DNS and beyond. Next, on the hardened security piece, I want to call out a few things. First is that Azure and AKS now has two options for container optimized. So adding to the general purpose Ubuntu and Azure Linux, you can now have Flatcar Container Linux, as well as Azure Linux OS Guard, which is a new version of Azure Linux that is container optimized, and it has an immutable file system. So two differences here is that you can run Flatcar today anywhere. It's available in several other cloud providers as well. And we have a large team of maintainers here, and actually the team that founded it and created it works at Microsoft. But you might want to also have a Microsoft created and optimized for Azure operating system, and that's what Azure Linux OS Guard is, in addition to the already general purpose Azure Linux that maybe a lot of you are already using. The next is pod sandboxing. You might already be doing pod sandboxing across your workloads, but that was public preview. So this is now generally available for cases that might require that individual kernel per application, individual kernel per pod, and that kernel level isolation or hypervisor level isolation inside of the pods themselves, not just between nodes. There's a ton of security announcements that I could spend a lot of time, and we're actually out of time already. So definitely take a look at the different announcements we have here, from the Bastion and Cloud Shell connection in private clusters, to the CLML 3207 policies, to the static egress gateway and Istio egress gateway integration to fully control the IPs that your applications exit towards, and policies to that egress as well, all the way to things like identity bindings and more that allow you to go beyond 20 FICs for a workload identity, and also you can now have any identity provider added to AKS. In the past, you can only add Entra, or Azure AD for those of you that have been here for a while. But Entra ID is the Microsoft identity solution. And a lot of you might have Okta, you might be running multi-cloud, you might want to reuse one of the other identity solutions. I definitely recommend Entra because it allows you to do conditional access, it allows you to do just in time. But if you already have everything somewhere else, you might even be coming from the fact that you started at GitHub, you were doing projects there, and you already have GitHub authentication. You can use that authentication in AKS now for your users, for your RBAC beyond that. So that is also something I'm pretty excited to have available in the platform today. And finally, on the last piece, cost. So and in the cost things, a few notable points that I have highlighted is the CSV export ability. So you can now export your cost analysis data to CSV and then just save it in storage for a number of purposes, from auditing to additional drilling. you now have the ability on the Azure pricing calculator to have scenarios in. So a lot of cases, you might rely on a lot of folks that know how Azure works and all the things that AKS uses to get the full price. Or you might mistakenly go in and think like, oh, this is the price for AKS, that's it. And you might not count things like managed NATs or VNets or egress costs or this. So now we created a scenario-based calculator where you can add your architecture and that will give you the full price for it. Give it a spin and give us feedback. The idea here is we want to be as transparent as possible for the price, and then we want to use things like Automatic and managed system pools to get you the lowest possible TCO of anywhere. And finally, keep in mind that you can always customize things like monitoring as well as network logs to have the specific namespace, the specific filter, specific applications, the right metrics and logs that you might want. And as I mentioned before, you have the ability in Fleet Manager to target the cheapest region. So not just inside of a region, I mentioned this before when I mentioned map, you can do that here. And I will end up here. We're 6 minutes over, so thanks for all of you that are staying a little bit longer. Give us feedback on the community calls. Sanket already mentioned we're running this monthly. You have the link on the screen, and you also have the GitHub community and the YouTube community where you can go and ask questions in GitHub. You can go to YouTube and check our previous videos and previous events. And I hope to see you in 2026, and happy holidays for everyone.
Awesome. Thank you, George, so much. I think this was really a great session, extremely dense with information. So folks, I think if you have any questions, we're just going to open up mics. I think most of the questions that came in the chat were answered. Richard, I know you had a question around does the deallocated scale down mode work with the new VM node pools? George, can we take that question maybe? Or Richard, if you want to come off mute and explain that more.
Yeah, so the allocate mode is not working with VM pools today. It will work in the beginning of the new year, but we actually are looking at exploring a few different options for how the allocate works, which involve studying a bit more why folks are using the allocate. So one of the reasons that a lot of folks are using the allocate for is things like caching and maintaining caching of images inside of nodes. And so instead of deleting them, they stop them. That's the big power of the allocate. However, we're also shipping very soon in Q1 something that we're calling node customization, which actually allows you to cache images as well as additional data inside of nodes, and then you scale with that cache. And so we build the image, we still build the image, but we add all that information inside of it, and then we scale with all of that. So with some of these things that we're launching, we're actually considering if that feature in cases like NAP and beyond still needs to exist. There's additional explorations we're doing with warm pools and more. And so we're looking at evaluating that a bit. If everything else kind of stays the same, we will support it in 2026 in VM pools. But if some of these things actually meet the fullness of scenarios and do it in an even better way, we might not continue to propagate it, but we're always open to your feedback if it's something that you definitely want to see.
Awesome. Thanks, George. There was another question from Michael around consolidation cycles, scheduling of consolidation cycles for NAP. I think, Michael, we did address that in George's talk about NAP as well. And then Wilson has a link, a follow-up link as well. If you have a follow-up question on that, feel free to come off mute and we can talk through that. Right, and if not, that's absolutely fine. Perfect. So as we close out, any other questions? Going once, going twice? All right. If not, then definitely been a great year with all of you guys. I think this is you guys all have been such an amazing community to work with, and we definitely look for more interesting developments with the community call as we get into 2026. So thank you all, and happy holidays. Right. Bye.
Ciao.